In this video, we're going to talk about the period and the frequency of a graph. And if you look up here at the top, and this you would find about a little ways down on page 2 in your notes. So if you look at page 2, period is the horizontal length of one complete cycle. And the way I like to kind of compare this is like a class period. How long does it take to complete one class period? What is it, 44 minutes, 43 minutes? I forget. See, it's been so long since we've been in school. But let's say it's 44 minutes. That would be the period of time that it would take for you to complete period 1 or period 2 or period 3. It would be 44 minutes, right? Well, the period is how long it takes to complete one curve. So if we look at this sine curve, a sine curve has an upward sweep, so to speak, and a downward sweep. So how long does it take to complete that full curve? It takes 2 pi. So a length of 2 pi would be the period. Okay, the same thing with a cosine curve. We're starting here at 0. Now, a cosine curve, remember, starts up, goes down to its minimum, and back up again. This is one full cosine curve. And look and see how long it takes for that to be completed, and that's a period of 2 pi. So how long it takes to complete one full cycle is what we refer to as period. Okay, now the next thing, if you look down below this at the bottom of the page, we talk about something called frequency. And we're going to constantly go back to page 2 if you need to look at the definitions of things. But frequency is the number of complete cycles every 2 pi units. Or as I sometimes like to phrase it, how many curves from 0 to 2 pi. So if we go back up and we look at these two graphs here, okay, you can see that we have one full curve from 0 to 2 pi. So we say that its frequency then would be 1, because it's the number of cycles that we see by the time we get to 2 pi. Or how many curves do we see from 0 to 2 pi? Well, we only see this is one curve from 0 to 2 pi. Let's look at this one, cosine curve. There is one curve from 0 to 2 pi. So the frequency here is 1, and the frequency here is 1. Okay, now we have these two formulas over here. We're going to talk more about them, I think, once we get to page 4. It'll make more sense. All of this will. But I want you to notice something here. We have period equals 2 pi over the frequency, and notice over here, frequency equals 2 pi over the period. So do you see that frequency and period are interchangeable here? Okay, and that's the important thing that I want you to see. And again, I think we're going to just put it to the test, and let's turn to page 4, and then I think it'll start to make more sense for you. All right, so if you look in the middle of page 2, you will see these two graphs right here. Actually, I'm sorry, I lied. That's on the top of page 4. My mistake. Okay, so these are on the top of page 4. And if you look at them, you'll notice that there's an addition of a letter that wasn't there before. So this A stands for the amplitude. Remember, that's the distance from the midline to the maximum, or the midline to the minimum. So in this case, my amplitude of this graph is a 1, and we can also determine amplitude by the number that's in front of the word sine or in front of the word cosine. This amplitude would also be a 1. Here's my midline, and the distance from my midline up to the maximum or from the midline down to the minimum. Now remember, if I want to find amplitude, I could do max minus min divided by 2 as well. But you notice, here's what I really want to focus in on, is we have this letter B. Okay, and what that letter B stands for is for the frequency. So if you would write this down, B equals frequency. Now, if you look at the bottom of page 2, frequency, remember, is how many curves we see from 0 to 2 pi. So if I look at this graph right here, how many curves do I see from 0 to 2 pi? Do you see that I only see 1? And so my B, which is my frequency, is 1. Now look at where B is. It comes right after the word sine. So look at the number that comes right after the word sine. It's a 1, right? If we don't have anything there, we understand it to be a 1. Same thing over here. Understand, you should see that this is a 1. So that means the b, or the frequency of this graph, is 1. And what that means is from 0 to 2 pi, I see one sine curve. Cosine curve. Now, which is not always going to be the case. So look at page 4. Let's look at the first question. So notice here, my amplitude is a 1, but look here, my frequency is a 2. So let's write that down. So I have amplitude is 1, and my frequency is 2. Now remember what frequency means. It means the number of curves from 0 to 2 pi. So this means that I'm going to see 2 sine curves. Not 1, but 2, from 0 to 2 pi. So just to give you a little sketch here. So I'm going to see 2 sine curves. That's a really bad picture. From 0 to 2 pi. Okay, so that's what this frequency means. Now, I have to take this and make it look nice and pretty on here. So if it takes me to 2 pi to get 2 curves, where do you think I'm going to end my first curve and start my second? Wouldn't that be in the middle of 0 and 2 pi? So then what I do is my first curve will start at 0 and it's going to end at pi. Okay, we'll make it fit, don't worry. So my first curve is going to be in here, and then my second curve is going to be in here. Okay, so let's just deal with the first part first. So I want to fit a sine curve right in here. So now remember the behavior of a sine curve. Well, it starts at 0, it ends at 0, and it should have 0 in the middle, right? So I'm going to put that 0 right there in the middle of pi over 2. Okay, now let's talk about what happens between the first and the second 0. Doesn't this usually go up to its maximum? Well, we know that the amplitude is 1, so its maximum is going to be at 1, right? But it's got to be in the middle. So I have, look at this, I have 1, 2, 3 boxes. So the middle will be 1.5. So I want you to go out to 1.5 and go up to its maximum and put a dot right there. Okay, I'm going to do the same thing. So there's my maximum. Now I'm going to do the same thing between the second and the third 0. So I've got 1, 2, 3 boxes. I'm sorry, that really is not a great graph there, and then I'm going to go down to its minimum, which would be at -1. So you want to put a dot right there. Okay. All right. So let me connect those. Oops, sorry about that. Okay, and there's my first sine curve. Now I want to repeat that again. So remember, the second sine curve starts at 0, ends at 0, and goes to 0, in the middle. So there we go. Here we go. We go up to a maximum. So count 1.5 boxes, go up to a maximum, count 1.5 boxes, and go down to its minimum. And whoops, we can connect those again. And there's your graph of y equals sine of 2x. Okay, so the frequency is 2. That's the number of curves you see from 0 to 2 pi. Now, I'm sorry you can't see my 2 pi, but it's under there. And let's just count. We've got 1, 2 full curves from 0 to 2 pi. Now, the other thing I just want to talk about first is the period of the graph. Now, if you go back and you look at page 2, read the definition. It says the horizontal length of one complete cycle. Well, how long does it take to complete one cycle? Look at how long it takes, all the way to pi. Okay? Now, we can use the formula if you look at the bottom of page 2. And let's use the formula to find the period of the graph. So if you were asked to find the period of the graph, right, that would be P equals 2 pi over the frequency. And we know the frequency right here is this number, which is a 2. So 2 pi over 2. So therefore, we know that the period is pi. And that's how long it takes to complete one full cycle. So it takes all the way to pi to complete one full cycle. All right, we should be able to move a little quicker through these questions. So we notice that the amplitude is 1 and the frequency is 2. So that means we're going to have 2 cosine curves from 0 to 2 pi. Okay, so let's just write a couple of things down. So again, my amplitude is 1. My frequency is 2. And we're going to have, I'm just going to kind of sketch it, 2 cosine curves from 0 to 2 pi. So that means 1, 2, and that would be 2 pi. Now we need to make that look nice and pretty. So really the most important part right here for the beginning is where is this on my x-axis? Okay, so if this is 1 curve, and then from here to here is 2 curves, this should be at pi, correct? Right smack dab in the middle of 0 and 2 pi. So I'm going to start at a maximum, go down to a minimum, and back up to a maximum by the time I get to pi. Okay, so let's make that look pretty. Okay, so our amplitude is 1, so that means I know that I'm starting at 1. And at pi, I'm finishing at 1. And then in the middle, which is pi over 2, I'm going down to its minimum. Okay, all right, now, I know that in between the maximum in the middle here, the minimum here, smack dab in the middle, I should be hitting the x-axis. So again, I think you have 3 boxes here, so you want to be at 1.5. Okay, just make sure that you are exact. And then I'm going to go 1.5 in between pi over 2 and pi. And then let's make that flare and look nice and pretty. Oops. Let me just make my dot bigger so it looks better. Okay, so there's the first curve. We're going to repeat it again. So from pi to 2 pi, we start up and we finish up. At 3 pi over 2, I should go down to its minimum. And then in the middle, which is a box and a half, and a box and a half, I am hitting the x-axis. So there we go again, and there we go again. All right, so let's just double check. So from 0 to pi, that's 1 curve, and from pi to 2 pi, that's 2 curves. So the definition of frequency is how many curves you have from 0 to 2 pi. I have 2. Okay, now, didn't ask it, but I'm going to go over it anyway because I think it's good practice. If they ask you for the period, remember the period is 2 pi over the frequency, which is 2. Okay, and I'm getting that right from there. And when I reduce that, my period is pi. Now remember what the period of a graph means. How long does it take to complete one full curve? And let's look at this. How long does it take to get one full curve? If we looked at the picture, we could see it and say, oh, that's a pi. If we didn't have a picture, and sometimes you won't, you can use the formula. All right, so let's look at y equals sine 1/2 x. Well, the amplitude is 1. Right, that's the number right in front there. And my frequency, is 1/2. Okay, so what that means is I'm only going to see half of a sine curve from 0 to 2 pi. All right, so when I do this, I say, well, let me just draw what a sine curve looks like. Here's a sine curve. Now, I'm only going to see half of that. So in other words, I'm only going to see this. That's half of a sine curve right there. Okay, and remember, by definition, this is half of a sine curve from 0 all the way to 2 pi. So if I'm looking down here at my little sketch, that should be 2 pi. So I want to take this thing right here that I outlined in blue, and I want to put it up here. Okay, so let's do it. I know I'm going to start at 0, 0. And I know I'm going to end at 2 pi 0. Because I'm just looking at what I have down here. So what do you think is going to happen in the middle here? Well, if 0 is the beginning, 2 pi is the end. In the middle, wouldn't that be the maximum? So then at pi, I'm going to go up to its maximum, which is going to be 1. Okay? And then at pi over 2 and 3 pi over 2, I know that, let me just kind of get this back. Here's my maximum. I know that I'm decreasing. I don't have exact values here. So I'm just going to sketch the best I can. And there we go. Okay. All right, so let's talk about the period of the graph. Well, remember, period is how long it takes to complete one full cycle. Actually, let's not use the equation. Let's just look at this. How long it takes to complete one full cycle. This is not a full cycle. Isn't this only a half cycle? So how much longer would I need to get the other half? So if I get only half of it by 2 pi, how long would it take me to get the other half? Wouldn't that be to 4 pi? Okay, so if I wanted to use the formula, which is totally okay, I would do 2 pi over the frequency, and I know the frequency is 1/2. And then really what you can do then here is you can do keep change flip, or you can just put this in your calculator, do 2 divided by 1/2. Now, if you're doing keep change flip, remember I would multiply this by 2 over 1, and I would multiply this by 2 over 1, and that would cancel out. And there's your 4 pi. All right, last one. So we can look and we can say, well, the amplitude is 1 because that's the number in front here. And my frequency is 1/2. So remember what frequency means. It means how many curves we're going to see from 0 to 2 pi. So I'm only going to see a half of a curve. So let me draw a full cosine curve. Okay, so there's a full cosine curve. So what this is saying is I'm only going to see half of a cosine curve. So I'm going to outline this in blue. That is half of a cosine curve. And by definition of frequency, that will be, how much of a curve are we going to see? We're going to see half of a curve from 0 to 2 pi. So I need to take what I've outlined in blue. Look at what's happening. I'm starting at the maximum and I'm going all the way down to its minimum by the time I get to 2 pi. Okay? All right, so let's see if we can convert that a little bit. So I know my amplitude is 1, so I'm going to start up at 1. And by the time I get to 2 pi, I should be down at -1. Okay, so let's talk about the middle here. So here's my maximum. Here's my minimum. Aren't I supposed to be hitting 0 or hitting the x-axis smack dab in the middle of the maximum and the minimum? So then here at pi is where I should be hitting the x-axis. So I'm going to put a dot right there. Okay, so now I know that my picture is not beautiful and it's actually not very accurate, but it was a sketch. So this point right here, which really should probably be over this way a little bit more, is my pi that we see up here. And then look at what happens. We're just going to kind of do the little flare, the best that we can. I know it's stretched out, but that's okay. All right, so there we go. And there's y equals cosine 1/2 x. Okay, now let's just see if we can figure out the period without doing the formula. So if it takes all the way to 2 pi to get a half a curve, remember, a period is how long does it take to get a full curve. How much longer would it take to get the other half of this curve? And hopefully you realize that that would be 4 pi. Okay, if not, you can do period equals 2 pi over the frequency, which is a half. Keep change flip just like the last one, and we will get 4 pi.